Hello. The purpose of this presentation is to help better define Hoya's freeform optical technology and to tell you more about the products in the category of Hoya freeform technology, what it is not, and how it is different from the other freeform technologies that are available today. And I'm also going to be presenting to you a new product that is being added to our Hoya freeform lineup, the Hoya Lux ID MyStyle. Freeform in the past 10 years in the optical industry has taken center stage in the discussion about where we're going with lens designs and progressive lenses. Hoya has been at the forefront of optical technology since our inception in 1941. If it has to do with bending light, Hoya is there, and Hoya is leading the way in technologies for vision care, consumer products, and in facets that touch our everyday lives. Hoya is there. And Hoya freeform technology is quite unique in the way we approach the design and the surfacing of freeform progressive lenses. So, to give some definition into who we are and what we do, we've arranged our technologies into two different lens series. One is the IQ and the ID. Products that fall in the IQ lens series include familiar designs that we've had available for some time in the conventional sense, the Hoya Lux Summit ECP and CD. Now we've added IQ to their names, and I'll explain to you why that is, why it's different, and why it is in a series of lenses on its own. I'm also going to describe to you the ID series of lenses, which includes a new product that we're introducing now called the Hoya Lux ID MyStyle. And this series of lenses also includes the ID, which is now renamed as the ID InStyle, the Hoya Lux ID Lifestyle, and the product formerly known as New Lux EP is the ID Single Vision. When we talk about the IQ series of lenses, the easiest way to define it is simply the optimization of the optics in conjunction with conventional designs. This illustration will help me clarify what that means. Every progressive lens starts off with a target design, and the target design is pictured on the top that shows you this was what the designer had intended for the design to look like when you do surface mapping or contour plots. When you take that semi-finished blank, where the target design is placed and molded onto the front, and put it through a conventional surfacing technology, what happens to that contour plot as a result of those powers is much different from what the target design was intended to look like. Using Hoya freeform surfacing and the IQ software technology, aspheric atoric curves, to optimize the optical performance of that same design, we take a look at the contour plots, and they're amazingly similar to what the designer had originally intended with the target design. So the comparison of target design with the Hoya freeform surfacing of that same design using the IQ aspheric atoric software, you can see that there is a vast improvement in the optical performance with a conventional design. That simply is our definition of IQ, and there will be other products added to the IQ series of lenses in the future. For right now, it consists of our Summit ECP and Summit CD. Optimized optical performance, that is to say, aspheric and atoric geometry, that is used in conjunction with a conventional design, and it's applied on the back surface with Hoya freeform surfacing and polishing technologies. Now, to best understand the ID series of products, you need to first be familiar with the integrated double surface technology. As the name implies, both surfaces of the lens are utilized to deliver an integrated design. IDS first considers the prescription and frame data to calculate a unique design that first isolates the design into two primary components and then distributes them to either side of the lens. The vertical progressive optics are placed on the front side, and that provides a quicker path for the eyes to track from the top to the bottom, distance vision to near. And the horizontal progressive component is placed on the back side, and the benefit of that is to broaden the horizontal zones and subsequently provide wider, clearer vision in all areas of focus. Both are integrated, and in the case of the ID MyStyle, both surfaces are Hoya freeform surfaced, offering the maximum amount of customization. The ID Lifestyle uses the same design elements, but has a standard vertical component, and that is molded onto the front surface of the blank, while the back side is fully customized and Hoya freeformed surfaced. That is the primary difference between Hoya freeform design and surfacing technology and others. And today we're going to introduce a new dimension to the Hoya freeform technology design. We've talked about the Hoya Lux ID Lifestyle, and so we can simply describe that as a standard element on the front side and customized on the back. The Hoya Lux ID MyStyle, formerly known as our ID, is fully customized. Components on the front and components on the back that are applied using the freeform surfacing technology. We're able to go one step further now in personalizing the design to the patient's objective measurements and subjective feedback and input. This is what we call personalized optics, and it resides in our Hoya Lux ID MyStyle. So the ID series of lenses begins with our ID single vision, formerly known as Nulux EP, because it does use integrated double surface technology and places that on a single vision optic, and it is customized right down to the prescription power for a single vision lens. Hoya Lux ID Lifestyle, a customized design using the double surface technology. It is standardized on the front, customized on the back, and it is customized according to the frame and the prescription powers. MyStyle, customized design, double surface technology, customized front and back according to the powers and the frame geometry. And now we have ID technology, personalized designs according to the power, frame, and subjective data. That is our definition of Hoya Lux ID MyStyle and the ID series of lenses. The real differentiator in Hoya freeform technology includes not only the design part of freeform, but also the surfacing, polishing, and design validation process. That is how we define Hoya freeform technology. It includes the ability to design to both front and back surfaces using specific elements of the design, applying them using freeform surfacing technology to both the front and or backside of the lens, using a super soft polishing technology to finish off and clean up the surface of both sides of the lens, and then after each and every lens has been fabricated, it's validated so that it is in accordance with the original design intent If it doesn't match and fit within the tolerances of standards, it goes back to the beginning and reprocessed. This is a total process knowledge which is proprietary and specific to Hoya freeform technology. Now, with as sophisticated of a platform as integrated double surface is, why and how would we want to go beyond that? Well, number one, because quite simply we can. There is a vast amount of knowledge, science, and resources that have been accumulated over the years in developing the freeform technology that we're able to take the collective strengths and make them to where we can actually customize and personalize a lens to a patient's needs and wants based upon their subjective input, which is going to increase your adaptations and patient satisfaction. So we're taking the foundation of integrated double surface technology and we're going to build upon it because of the vast experience, knowledge, and design library that we have to use advanced technology to create a personalized vision experience. And this is the design approach and philosophy that leads to the MyStyle. We start with the basic foundation of integrated double surface design. It is unique in that we can take the design, split it into its two primary components, and utilize both surfaces of the lens to distribute those components. So if you were to be able to take a Hoya progressive lens, which has been designed and fabricated using the integrated double surface technology, what you would find is that the front surface is not in and of itself a progressive lens design. It is showing the vertical magnification. You could do a cross cut and look at the back surface. It too is not a progressive lens design in and of itself. It contains only the horizontal magnification of a progressive design. It is not until you integrate both front and back surfaces together that you have what we know as a progressive lens optic. Utilizing both the front and the back surfaces, an aspheric front, an aspheric back, an atoric front, and an atoric back. All of that combined together is what the integrated double surface technology is. Now, very important to the development of the design is its evaluation and validation process to make sure that the image quality that is reaching the retina, the eyes, and to the brain where we actually see is compatible to the prescription, to the powers, to the frame, and to any other parameter that is used to create a customized or a personalized design. To better illustrate how the Hoya design evaluation and validation process works, let's look at the flow of image information as it enters the front surface of a progressive lens all the way through to how those images end up being perceived by the brain. Let's begin with the basic design. Now, until the advent of freeform design and surface technologies, all of the design parameters existed here on the front surface of a semi-finished blank. This is what I refer to as a static design because the actual progressive optics could only be altered by a change in the lens blank, which is a very inefficient way for manufacturing and remanufacturing. IDS technology uses this surface to capture and separate only part of the design performance. This allows much better control of the quality of that surface, and when combined with the secondary part of the design and the optical performance on the backside, we have far more enhancements that can be made to both as compared to conventional static designs. But the eye receives optical information on the retina, and here is where the real science is applied to Hoya freeform designs. By applying numbers and values to these images, we can virtually simulate how the eye is interpreting that information. Then we analyze it, correct it, and enhance the image into an image that is easier for the brain to process. And that is where we actually see on the brain. So when we talk about how we optimize the optical performance, what we're referring to is what we do at points A and B here on the flowchart. When you hear us talk about customizing a design, that really happens at points B and C. Personalization concentrates on the quality of the image information at points C and D so that we can alter the surface geometry at A and B. Now, if you follow that path of image information to where it's projected onto the retina, we use balanced view control, a unique Hoya method for analyzing, mapping, and evaluating that information on many levels in both static and dynamic environments. The feeling of motion to the wearer that's often associated with a multifocal comes from the changing magnification and image shapes as the eyes move across the plane of the lenses. This can produce confusing information to the brain. To measure this subjective feeling, we apply a mathematical model and convert it into a map where it can be evaluated and corrected. The benefit is a more confident and secure feeling for the wearer. Presbyopes who previously rejected conventional progressive lenses will experience and appreciate the improved experience. We use ray tracing to capture the image at every point and angle of view throughout the lens. We convert this information to a mathematical value, which is based on the degree of retinal image blur. This is a sum of the total deformation involving skewed deformation in static situations and dynamic image deformation. For the purpose of this illustration, we assume that the pupil is transmitting a 4 millimeter beam of light, although in reality it is analyzed over a range of pupil sizes. Through this concentrated beam are about 100 individual light rays carrying different bits of image information that are separately captured and plotted in what is called a spot distribution diagram. It is here that we can identify both lower and higher order lens aberrations. The spot distribution plot is translated to a visual acuity data. The variations within the visual acuity data are plotted onto what we call a clearness index map. So with all this science, it means that the wearer, your patient, enjoys a higher definition of clarity, much clearer vision, wider areas of unhindered vision at every distance of gaze, and the unprecedented control of lens aberrations, and that interprets into a higher level of visual acuity. And so the addition of personalization and the ability to accurately apply that personalization to a lens surface is the added dimension in our design philosophy that we call IDEA, Intelligent Design by Extensive Analysis. So in reality, this is how we make a MyStyle your style. It begins with the typical objective measurements that we do with even conventional progressive lenses. We ask for fitting heights and monocular PDs. In addition, we're going to calculate the design around vertex distance, panoscopic angle, face form angle. Those are the measurements that give us the position of the lens in front of the eye. Now, you can measure these values, or we can use averaged or default values if necessary, and it can be done through your conventional methods of measurement and fitting. However, by using some of the new electronic devices like Hoya's Visu Real, we can come up with far more customized and personalized designs based upon measured values that are extremely accurate. The better the information that's supplied, the better the result is with the eventual design. But this is the real component that differentiates MyStyle from any other freeform product available. It's the MyStyle identifier. This is an online consultation and design tool that allows the ECP to work with the patient on gathering not only the typical objective measurements, but we also interview and consult with the patient on their subjective input to come up with a design that is personalized just to them. By going online and collecting all this data, we can actually, in the office, come up with the design profile that fits exactly to the patient's needs and wants. So once the ECP has signed on with their unique name and password, we begin to put together the pieces that are necessary for a MyStyle design. And that includes prescription measurements, many components of which can be customized, frame measurements, which can be transferred from a remote frame tracer or from any kind of electronic measuring device like the Visu Real. And the more specific and the better the measured values that we're inputting in here, the more personalized that the design becomes. And then this is the interesting part that really gets to the heart of the subjective material. We can interview the patient to find out what their past lens wearing experiences was, whether it be single vision, a bifocal, or another progressive lens. We can find out what their experience or what their subjective satisfaction level was wearing their prior designs. The more they like the design, the more we'll be able to duplicate that visual experience for them in their new personalized design. And then finally, we're going to spend time with the patient finding about their lifestyle and the requirements for their lifestyle by showing them a series of icons that represent different facets of their life: business, personal, sports, hobbies. All of these icons represent a part of their vision experience and how they weigh the importance or rate their importance of these different lifestyle requirements. You'll need to choose up to 5 different of these icons and place anywhere from 1 to 5 stars depending upon the importance for the patient. This then personalizes it to how they're going to use this in real life. The sum of all of this information will create what we call a personal vision profile. This is to let the patient know what they can expect as far as their vision experience is concerned, and what we've just done to personalize the lens and the design to their needs and their wants. You'll be given a copy of this personal profile at the end of the consultation session. And when the lenses come back from the laboratory, I want to make a couple of things very clear here. This is an as-worn type of lens, which is to say there have been adjustments made to the red powers that you'll read on the lenses to adjust for things like the marginal astigmatism due to the variations in vertex distance, panoscopic angle, and facial wrap of the lenses. These are adjustments that are made to the red powers so that the patient will actually see what was intended through the powers that were prescribed. And most of your conventional lensometers are not going to be able to interpret this, so we're going to give you a document that will give you both the ordered powers and the powers that you will now read through a lensometer so that the patient will be able to see as refracted in the ordered powers. This is what we do called the as-worn position adjustment of RX powers. So whether we're giving specific measured values or whether we're using conventional or averaged values for how the lens is positioned in front of the eye, what is that impact? What is the difference between that? Well, using the clearness index, we can give you a comparison of what those default values or averaged measurements that we'll use rather than measured values as compared to what true measured values will do to the actual outcome of the design. And if you can see, there is an outline between those two that will show you a simulation of what the patient can expect, whether or not we personalize this with measured lens positioning values or averaged. The more information that you can provide in the collection of the data in the identifier for a MyStyle lens, the more personalized the visual experience becomes for each and every patient. The better the design performs, and the happier the patient, and the bigger the smile. So at this point, what we have is a design profile or a direction that is based upon 9 patterns or directions that we further customize when we compile all of the objective and subjective measurements. And we come up with a direction for maximizing, according to the patient's desires, distance vision, intermediate, near, a balance of all 3, or some combination of those. This is the profile that we used to then start truly personalizing it with all the other information. The more information you can provide, the more personalized the experience. We'll take all of the parameters that have been collected in the identifier, and we will put this information through a circular design process of evaluating and validating that we're able to provide the patient exactly with what they want and what they need, given all those parameters. The highest degree of personalization of any optic that is available right now, creating a lens according to the patient's wants and needs, and very satisfied patients. That is the goal and the aim of the Hoya MyStyle. Now, who's a good candidate for this type of visual experience? Who wouldn't be a candidate? Every patient, every day, should be our goal to be able to educate our patients as to what technology is capable of doing to provide them with the best vision experience available. By using the same design year over year over year with the same patient is not exactly best practices. Now we have the ability to personalize it according to every change and nuance of that patient and their prescription and their frame. And this is a product that is specifically for the independent eye care professional. This provides you some exclusivity to be able to do something that they cannot get anywhere else. And of course, you would expect this kind of technology from Hoya, Hoya's freeform technology. We're here to help. We're here to serve. We hope we can be of service to you. Thank you.